Opening the shell script, we can see that it is welcoming the user, along with the current date and the list of menu. Entering 1 will show the directory. Entering 2 will show the files in the directory. Entering 3 will change the directory. Entering 4 will create a file. Enter the name of the file along with the text in it. It will also ask if the text wants to be encrypted. If yes, you can see that the encrypted file is in the downloads directory along with the ciphered text in it. Entering 5 will encrypt a file. Enter the text and it will output the plain text. Entering 6 will run Apache 2 and MySQL servers. It will also look for the processes of the web servers. Entering 7 will stop the servers. And lastly, entering 0 will exit the program. We have multiple functions in the script. The first ones are start service and stop service. Service start is starting up the web service. PS is process start. Grep is for finding the processes with it. In J we have if and else condition that uses cd for the directory. The go back function, if the answer is 1, then it will call the menu function. If not, it will exit the program. The function create file gets two variables. It will be for the text and the file name. If the user wants it encrypted, entering 1 will echo append that takes the text and translates it. TR function that gets A and Z, and the text starts with X through Z and A through W. In the decrypt function, the text 2 parameters shown in the encrypt translate just swap positions. The menu function just shows the navigation through if-else function.
The group focused on creating a mobile application using Android Studio to create a Caesar cipher and affine cipher system. Once the user opens the application, he will first be redirected to the home page of the application where he can choose if he wants to use the Caesar cipher or the affine cipher. If he chooses the Caesar cipher, he will be redirected to the page of Caesar cipher where he would need to choose between encryption and decryption. For this program, we limit the users when it comes to inserting special characters, numerical values, and string messages depending on the information that must be provided. The system also doesn't allow the users to leave a blank values to prevent errors from occurring. In cryptography, a Caesar cipher is categorized as a substitution cipher in which the alphabet in the plain text is shifted by a mixed number down the alphabet. In the Caesar cipher's encryption, the user will be asked to enter a plain text and ciphertext. For example, the user types sample text as plain text and the values of 5 as cipher. The result of the encryption would be XFRUQJ RJXXFLJ. In our system, we have the copy-paste feature to make it easier for the user to decrypt the message. As you can see, once you decrypt the message generated by the encryption, the output will be sample text, which means that the process was done in the right manner.
The affine cipher is a type of monoalphabetic substitution cipher, where each letter in an alphabet is mapped to its numeric equivalent, encrypted using a simple mathematical function. Meanwhile, the affine cipher also lets the user choose if he wants to encrypt or decrypt. Affine cipher is different from Caesar cipher as it does not only have one key but two keys. For example, In the affine cipher's encryption, the user types sample message and the multiplicative key is 5, while the additive key is 9. The result would be VJ, RGMD, RDV, VJND. We will now copy-paste the encrypted message and move on to the decryption of the affine cipher. After we have pasted the ciphertext and used the same two keys from the encryption, you will see that the plain text is sample message. To explain the program made to create the cryptography algorithms, we're going to show the encryption XML and Java files of Caesar cipher and decryption XML and Java files of affine cipher. For Caesar cipher, we use multiple for and if loops to create iterations used to process the characters of the string. After doing so, the characters are then processed based on their length to check if it's within the alphabet. If it is, then the character will be processed to see if the value is greater than z. If it is, then we need to subtract 1. After that, the encrypted characters will be combined together in one message.
Next is the affine decryption, which is challenging to say the least. Here we use string builder to be able to append the characters which will be separated and processed with the use of for and if loops that iterates based on the length of the message. However, before all of this, we have to compute for the inverse to be able to decrypt the message. We used big integer mod inverse to make use of a method that will calculate the modulus of the inverse of the given value as this to the power of -1 mod n. After doing so, the loops will check if the character is a letter or not. If yes, then we will proceed to the computation and gets it mod. After doing so, we will append the character and turn it into string. To limit the users from entering wrong information or missing information, we use try-catch and inserted Android digit in the XML file of the program to prevent the users from entering the wrong information in the edit text. Lastly, we use Clipboard Manager to be able to use copy and paste with the use of Clipboard service. That's all. Thank you.